Hello everyone, my name is AYUSHI PRAKASH. I am from BTech Mechanical third year. Today I am here to discuss few topics from internal combustion engines. The topics which we will cover in this presentation are introduction of engine, basic engine component, the working principle of engine, in this we will cover about 4-stroke engine, 2-stroke engine and carburation. What is engine? An engine is a device which transforms one form of energy to another form. However, while transforming energy from one form to another, the efficiency of conversion plays an important role. Normally, most of the engine converts thermal energy into mechanical energy and therefore they are called heat engines. Now we will look to some of the basic components in heat engines. The heat engine consists of spark plug, inlet valve, exhaust valve, cylinder, piston, connecting rod, cylinder blocks, and crank. Cylinder blocks. The cylinder blocks is the main supporting structure of the various components. The cylinder of a multi-cylinder engine are cast as a single unit called cylinder blocks. The cylinder head is mounted on the cylinder blocks. The cylinder head and the cylinder blocks are provided with water jackets in the case of water cooling or with the cooling fins in the case of air cooling. Cylinder head gaskets is incorporated between cylinder blocks and cylinder heads. The cylinder head is held tied to the cylinder block by number of bolts. The bottom portion of the cylinder block is called crankcase. The cover called crankcase, which becomes a sump for lubricating oil, is fastened to the bottom of the crankcase. The inner surface of the cylinder block, which is machined and finished accurately to cylindrical shape, is called bore or face. Cylinder, as the name implies, it is a cylindrical vessel or space in which the piston makes a reciprocating motion. The varying volume created in the cylinder during the operation of the engine is filled with the working fluid and subjected to different thermodynamic process. The cylinder is supported in the cylinder block. Combustion chamber, the space enclosed in the upper part of the cylinder by a cylinder head and the piston top during the combustion process is called the combustion chamber. The combustion of fuel and the consequent release of thermal energy results in the building up of pressure in this part of the cylinder. Inlet manifold. Inlet manifold, the pipe which connects the intake system to the inlet valve of the engine and through which air or air fuel mixture is drawn into the cylinder is called inlet manifold. The exhaust manifold, the pipe which connects the exhaust system to the exhaust valve of the engine and through which the products of combustion escape into the atmosphere is called the exhaust manifold. Inlet and exhaust valves are commonly mushroom shaped poppet type. They are provided either on the cylinder head or on the side of the cylinder for regulating the charge coming into the cylinder and for discharging the product of combustion from the cylinder. Spark plug, it is component to initiate the combustion process spark ignition engine and is usually located on the cylinder head. Connecting rod, the interconnect or the it interconnects the piston and the crankshaft and transmit the gas forces from the piston to the crankshaft. The two end of the connecting rod are called as small end and the big end. Small end is connected to the piston by a gudgeon pin and the big is connected to the crankshaft by crank pin. Crankshaft, it converts the reciprocating motion of the piston into useful rotary motion of the output shaft. In the crankshaft of single cylinder engine, there are a pair of crank arm and balance weight. The balance weight are provided for static and dynamic balancing of the rotating system. The crankshaft is enclosed in the crankcase. Piston ring fitted into the slots around the piston provide a tight seal between the piston and the cylinder wall, thus preventing leakage of the combustion. Camshaft. The camshaft and its associated part controls the opening and closing of the two valves. The associated parts are push rod, rockers, arms, valve, springs, and taper. This shaft also provides a drive to ignition system. The camshaft is driven by crankshaft through timing gears. Now we will look at the working principle of four-stroke engine. Four-stroke engine. In a four-stroke engine, the cycle operation is completed in four strokes of the piston or two revolutions of the crankshaft. During the four-stroke, there are 5 events to be completed with suction, compression, combustion, and exhaust. Each stroke consists of 180-degree to crankshaft rotation and hence a four-stroke cycle is completed through 720 degree of crank rotation. So, in an ideal four-stroke engine consists of four-stroke suction or intake stroke. Suction or intake stroke starts when the piston is at top dead center and bottom to move downward. The inlet valve is assumed to open instantaneously, and at this time the exhaust valve is in the enclosed position. Due to the suction created by the motion of the piston towards the bottom dead center, the charge consisting of fuel air mixture is drawn into the cylinder. When the piston reaches the bottom dead center, the suction stroke ends and the inlet valve closes instantaneously. Compression stroke. The charge taken into the cylinder during the suction stroke is compressed by the return stroke of the piston. During this stroke, both inlet and the exhaust valve are in closed position. The mixture which fills the entire cylinder volume is now compressed into the clearance volume. At the end of the compression stroke, the mixture is ignited with the help of the spark plug liquidated on the cylinder head. An ideal engine is assumed that burning takes place instantaneously when the piston is at the top dead center, and hence the burning process can be approximated as heat addition at the constant volume. Expansion or power stroke. The high pressure of the burnt gases force the piston towards the bottom dead center. Both the valves are in closed position. Of the four stroke, only during this stroke power is produced. Both pressure and temperature decreases during expansion. Exhaust stroke. At the end of the expansion, at the end of the expansion stroke, the exhaust valve open instantaneously and the inlet valve remain closed. The pressure fall at the atmospheric level. A part of the burned gases escape. The piston starts moving from the bottom dead center to the top dead center and sweeps the burnt gas out from the cylinder almost at atmospheric pressure. The exhaust valve closes in the piston reaches top dead center. At the end of the exhaust stroke and some residual gases trapped in the clearance volume remains in the cylinder. Two-stroke engine. In two-stroke engine, the cycle is completed in one revolution of the crankshaft. In this engine, the filling process is accomplished by the charge compressed in crank or a blower. The induction of compressed charge moved out the product of combustion through exhaust port. Therefore, no separate piston stroke are required for this two operation. Two strokes are sufficient to complete the cycle, one for compressing the fresh charge and the other for expansion or power stroke. Here is the mechanism of two-stroke engine. Carburation. The process of formation of the combustible fuel air mixture by mixing the proper amount of fuel with air before admission to engine cylinder is called carburation. The device used for this job is called carburetors. Factors affecting carburation. The factors that affect carburation are the engine speed, the vaporization characteristics of the fuel, the temperature of the incoming air, the design of the carburetors. Air fuel mixture. Fuel and air are mixed in the form of three different types of mixture, which are chemically correct mixture, rich mixture, and lean mixture. The mixture which contains less air than the stoichiometric requirement is called rich mixture. The mixture which contains more air than stoichiometric requirement is called lean mixture. Here is the simple mechanism of carburetor. The simple mechanism of carburetors says carburetors are highly complex, so it consists of a flat chamber, fuel discharge nozzle, metering and a metering orifice, venturi, a throttle valve, and a choke. The float and a needle valve system maintains a constant level. The float goes down, thereby opening the fuel supply valve and admitting fuel. When the designed level has been reached, the float closes the fuel supplies, thus stopping the additional fuel flow from the supply system. During suction stroke, air is drawn through the venturi. As already described, venturi tube is a tube of decreasing cross section with a minimum area at its throat. Venturi is also known as the choke tube and is shaped that it offers minimum resistance to the air. Correspondingly, the pressure decreases, reaching a minimum. From the float chamber, the fuel is fed to the discharge jet, the tip of which is located in the throat of the venturi. Because of the differential pressure between the float chamber and the throat of the venturi, known as the carburetor depression, fuel is discharged into the air stream. The fuel discharge is affected by the size of the discharge jet and it is chosen to give the requirement air fuel ratio. The pressure at the throat at the fully open throttle condition lies between 4 to 5 centimeter of mercury below atmospheric and seldom exceeds 8 centimeter mercury below atmospheric. To avoid overflow of the fuel through the jet, the level of the liquid in the float chamber is maintained at the level slightly below the tip of the discharge jet. This is called the tip of the nozzle. The difference in the height between the top nozzle uh, top nozzle and the float chamber level is marked by H. So essential parts of carburetor consist of fuel strainer, float chamber, main fuel metering and idling nozzle and choke or throttle. The fuel strainer, it prevents possible blockage of the nozzle by dust particle. It consists of a fine wire mesh or other type of filtering device, cone shaped or cylindrical shape. The strainer is usually removable so that it can be taken out clean thoroughly. It is retained in its seats by the strainer plugs or a compression spring. The float chamber, it supplies the fuels to the nozzle at the constant pressure. The float in the carburetor is designed to control the level of the fuel in the float chamber. This fuel level must be maintained slightly below the nozzle outlet holes in order to provide the correct amount of fuel flow and to prevent leakage of the fuel from nozzle when the engine is not operating. The main metering or and idling system. The main metering system of the carburetor controls the fuel feeds for cursing and fuel throttle operation. It consists of three principles. The fuel metering orifice through which fuel is drawn from float chamber, the main discharge nozzle, the passage leading to the idling system. The three functions of the main metering system are to proportion the fuel-air mixture, to decrease the pressure at the discharge nozzle access exits, to limit the air flow at full throttle. The choke and the throttle. The choke is a control on a carburetor to adjust the air fuel mixture when the engine is cold, while throttle is valve that regulates the supply of fuel air mixture to an internal combustion and thus control its speeds. A similar valve that controls air supply to an engine. Thank you.